Welcome back to my computer learning series, that is learning computer with seeing the natural sights of Indian village or Bharatiya village. And Swagatam. In the previous lecture, we saw that there are different media for data transmission, like twisted pair wire, coaxial cable, microwave system, and lastly we see that the communication satellite. uh, and before going to the next topic, once again I want to tell you that, as earlier Get Willy and Get Handler had said you that this is the area of Maharshi Jayaprasadeswar Gupta of 7th BC, and he has written a book called Brahmandotpati. This named as Brahmandotpati, and when I will get that book, I must explain about what is written in that. So now let again come to the our point. The next data transmission medium is optical fibers. So let's talk about the optical fibers. What is optical fibers? So let us start and see how optical fibers are used in data communication. Uh, so optical fibers are hair thin thread of glass or plastic used as data transmission medium, like copper wires or coaxial cables. However, unlike copper wires or coaxial cables, they transmit light signal instead of electrical signal. As light travels much faster than electricity, optical fibers can transmit data at much higher speed than copper wires or coaxial cables, with no significant loss of intensity over long distances. And it is made of glass, plastic or silica, and plastic fibers are least efficient but are cheaper and more rugged. Uh, while glass or silica fibers are much smaller and their lower attenuation makes them more suitable for high capacity channels. So physically, a fiber optical cable consists of three concentric layers. Uh, the first is that is inner core and a cladding around it, and the outer protective coating. Inner core has a diameter of about 8 to 200 micrometers and consists of a bunch of optical fibers. The cladding around it is made of plastic or glass and has a refractive index less than that of the core. The characteristics of light propagation depends primarily on fiber size, its construction, refractive index profile, and nature of light source. And the outer protective coating is made of plastic. The main components of an optical fiber communication system: the sender side electrical to light wave converter converts uh, the sender side consists of uh, a electrical converter which convert electrical to a light wave converter converts electrical signals into light signals. It uses either a light emitting diode, abbreviated as LED, or a laser diode to convert electrical signals into light signals. It then transmits this light wave over the optical fiber to receiver's end. The receiver side light to electrical wave converter detects the light waves and converts them back to electrical signal. It uses the receiver side light, and it uses photoelectric diode for this purpose, that is converting electrical wave into light waves. They use a photoelectric diode, and then an amplifier is used to amplify the signal and send the electrical signal to the receiver. And optical fibers have flowing advantage. So see the some advantage of optical fiber. First is large bandwidth. Optical fibers can transmit large volumes of data at very high speed and long distances. They can have 10 to 100 times greater bandwidth than the best coaxial cables, depending on the number of fibers bunched in inner core. A fiber optic cable consisting of a bunch of 20 optical fibers can support more than 2 lakh voices channel. Next point is immunity to electromagnetic interference. So optical fibers are made of glass, plastic, hence magnetic or electrical interference which cause errors in other media, especially in twisted pair wire, does not affect optical fiber transmission. Consequently, optical fiber communication systems do not require complex error checking and correction mechanisms, which other media that are sensitive of electromagnetic interference requires. This reduces the design cost and overheat associated with error checking and correction. And the next point is low loss. Light signals can travel at much higher speed than electrical signal with no significant loss of intensity over long distances. Hence, any data communication system using electrical signals such as copper wire or coaxial cables requires repeater at short intervals along the way to intercept and amplify electrical signals. Light signals also need amplification, but at much longer interval than that of electrical signals. Hence, an optical fiber communication system does not require signal repeaters at short intervals, resulting in reduced cost. Now, this next advantage is a small size and lightweight. A small size and lightweight. Fiber optic cables are much smaller and lighter than copper wires or coaxial cable. For example, a fiber optic cable with a core and a cladding of 0.125 millimeter diameter and 3.5 millimeter outer protective coating has the same data transmission capacity as 900 twisted copper wire pairs with an 8 centimeter outer diameter and weighing 100 times more. Size and weight are important factors when considering conducts running under overcrowded city streets. In some large cities, there simply is no room for additional bulky copper wires. In this case, use of smaller and lighter fiber optic cable is very effective. Now the next advantage is that security. Optical fiber offers increased security against unauthorized tampering of information, since it is extremely difficult and expensive to tap optical signals. जय श्री राम, ओम नमः शिवाय, ओम नमः शिवाय। जय संकट मोचन हनुमान जी की जय, संकट मोचन हनुमान जी की जय, बजरंग बली, जय बजरंग बली, जय बजरंग बली। Jai Bajrang. Now security. On the security point, optical fiber offers increased security against unauthorized tampering of information, since it is extremely difficult and expensive to tap optical signals. Next, advantage is safety and electrical insulation. Optical fibers, being insulators, provide electrical isolation between source and destination. Hence, they are from hazards due to electrical spark and are safe to use in places where it is unsafe to use electrical conductors. And the last advantage and point regarding advantage is analog and distance signal transmission. Optical fiber enables transmission of both analog and digital signals, as analog transmission system continuously varies light intensity, whereas digital transmission system turns light source on and off. So these are the advantage of optical fiber for data communication use, for the use of data communication. Now, however, there is a disadvantage also. So see what are the disadvantage of this optical fiber system. The first one is that optical fibers, being fragile, cannot turn at sharp corners. They can turn at corners having radius of at least a few inches. This creates problems in physical laying of fiber optical cables. And the next disadvantage is that aligning and joining two fiber optic cable is not so simple and easy as for twisted copper wire pairs or coaxial cables. It requires a special equipment to do so. So advantage of optical fibers have made them a preferable data transmission medium for many applications involving television, telephone, computers, etc. Hence they are widely used today. Now let's talk about the next topic in this line is that data transmission speed. First see what is data transmission speed uh, of this communication system. So and data transmission speed is decided by bandwidth of the communication system. So let's first see what are there. So bandwidth of a communication system refers to its data transfer rate, amount of data that it can transfer per unit of time. It is analogous to road's width. Wider a road, the more traffic it can handle in a given time. Similarly, higher the bandwidth of a communication system, the more data it can transfer in a given time. So bandwidth is measured in bits per second, (bps), and it is also known as baud. Generally, baud is identical to bits per second. Hence, a rate of 300 baud means 300 bps. However, technically, baud refers to number of signals changed per second. Hence, using more sophisticated coding techniques, one baud can represent 2 or even 2 bps. However, for most communication system, one baud represents one signal change per second and is equivalent to 1 bps. So that is, in baud there may be 2 or 3 bps also, but generally it is considered that one baud consists 1 bps, that is 1 bit per second. Now, based on data transmission speed, three basic categories of communication channels are, that is paths are, the narrow band or sub voice grade channels have a speed in the range of 45 to 300 baud. Low speed devices such as low speed terminals and communication system for low data volumes such as telegraph line use narrow band channels. And second one is voice band channels have a speed up to 9600 baud. Their major application is in ordinary telephone voice communication, hence the name voice band. Communication systems for data transmission from slow input output devices to central processing unit or vice versa use voice band channels. Next is the broadband. In broadband channels, the broadband channels have a speed of 1 million baud or more. Communication systems for transmission of large volumes of data at high speed, such as high speed computer to computer communication or data transmission to several different devices simultaneously, use broadband channel. Cost of data transmission service increases with speed. Hence, a thorough analysis of business needs and associated cost is necessary to make a proper choice of communication channel for an application. So these are the data transmission discussion on the data transmission speed. Now now we should see the next topic of this lecture is digital and analog data transmission. Digital and analog data transmission. So let's see what are digital and analog data transmission. And you are enjoying the beautiful natural sights of Bharatiya village or Indian village. This is the, you are seeing a greeny sights of Indian village. Now let's talk about the data and analog data transmission. So communication system that transmit data by means of electrical signals may use either digital or analog signal. Analog signal is a power range that varies continuously. Amplitude of an analog signal is measured in volts and frequency in hertz. Higher the frequency, the more number of times it crosses the time axis. On the other hand, a digital signal is a sequence of voltage pulses represented in binary form. Computer generated data is digital, whereas telephone lines used for data communication in computer network usually carry analog signals. When a data communication system transmits digital data on an analog facility, it must first convert it from digital to analog form at sender's end and from analog to digital form at receiver's end. And for this, modulation techniques is used. So now let's define modulation. Modulation is the technique of converting a digital signal to its analog form, and demodulation is the reverse process of converting an analog converting an analog signal to its digital form. And there are three forms of modulation techniques, that is amplitude modulation, frequency modulation, and phase modulation. We see the brief definition of these three. So first, see amplitude modulation, abbreviated as AM. Amplitude modulation represents two binary values 0 and 1 of digital data by two different amplitudes of the carrier signals, keeping frequency at phase constant. Voice grid lines use amplitude modulation up to 1200 bps. However, amplitude modulated signals are sensitive to impulse noises that arise due to electrical spark near transmission lines. The second one is frequency modulation, FM. Frequency modulation represents two binary values of digital data by two different frequencies, keeping amplitude and phase constant. Also known as frequency shift keying, abbreviated as FSK. This mode is less suitable to error than amplitude modulation. It is also easier to design devices based on FSK, that is frequency shift keying, because discrimination between two frequencies is simpler than detecting phase change. Hence, frequency shift keying FSK scheme is preferred for medium speed combination like 1200 to 2400 bps. And the third one is the phase modulation, abbreviated as PM. Phase modulation represents two binary values of digital data by shift in phase of carrier signal. That is, a sine wave with phase 0 degree represents a digital 1 and a sine wave with phase 180 degree represents a digital 0. This technique is more noise resistant and efficient than both amplitude modulation and frequency modulation techniques. For a higher speed transmission of 9600 bps, phase modulation is more reliable and preferred to other methods. So with this topic, I would like to end this lecture here. And before ending this, again I want to tell संकट मोचन हनुमान जी की जय, जय हनुमान जी की, जय हनुमान जी की, जय हनुमान जी की। ओम नमः शिवाय, ओम नमः शिवाय, ओम नमः शिवाय, ओम नमः शिवाय।